All right, electricity students, just a little more talk on AC theory, a little review and recap, and we're going to kind of dig into your house and start talking about the circuitry of your house. Last week, we reviewed electrical transmission. That's everything coming from the power plant, traveling great distances on those high tension lines throughout the country, getting down to, we learned about transformers, our ability to step up and step down voltages depending on our needs. Remember, we step up the voltage, that increases the voltage, but it lowers the current. That allows us to transfer electricity great distances more efficiently. Why? Low current means skinnier wire. Skinnier wire means less copper. Less copper means less money. So we've got the ability to transfer more efficiently with that higher voltage and lower current. But when we get to our house, we get to our neighborhoods, we need to use that electricity. That high voltage is no good for us. We need to step it back down again at the point of use, which is our homes, our businesses, office buildings, whatnot. So we're going to go from that secondary of that last transformer into your house, and that's what we're going to be talking about today. All right, so I'm going to draw the schematic version of our transformer, which is our two coils with our iron core, and we know that this side of the transformer is our primary, this side of the transformer is our secondary. In this particular case, in our residential areas around here, anywhere between 3,000 and 7,000 volts on the primary. Goodbye, you're gone. All right, this is real dangerous stuff. This is the top of those wooden telephone poles in all of our neighborhoods around our houses. We have those hurricanes, we have those wind event storms, tree limbs coming down. You hit one of these primaries and it falls to the ground. This voltage, this pressure, this electrical pressure will cut through asphalt like butter. And we've seen that in my neighborhood. Actually, the last few months ago, we had that storm. That high tension line, or I should say that high voltage primary side, came down the street and sliced right through the asphalt like it was nothing. Now let's talk about the secondary side. The voltage of our secondary is 240 volts. And that voltage is a lot more usable. The current is a lot higher, and that's going to allow us to power all those consumable appliances inside of our house. So let's take it from here. Okay, so our secondary side, we've got what we call line 1 and line 2. And between these two lines, the electrical pressure that we're dealing with is that 240 volts. Now, this is great for all those large appliances. But believe it or not, in our houses, we're actually using smaller components, smaller devices. We're plugging our cell phones in, we're powering our TVs, we're charging anything that's battery powered, and that 240 volts is still too much electrical pressure. So we need to figure out a way to divide this up. And we're not going to use a transformer. We're going to actually do this little trick here. And what we're going to do is what we call a tap. We're going to make a connection to the center of that secondary coil. And by doing that, we are creating this third leg in the system of your house. This leg is what we call the neutral. And eventually you're going to find out when we talk more about grounding, this is attached to the earth. All right? And that's how we create that neutral. That's also how we figure out ways to protect homes, protect people's houses, equipment, and the people themselves inside that house from short circuits and fires and all those sorts of things. And that's actually by creating a very efficient path for electrons to flow if there is a problem. And that will open up any sort of overcurrent device in the system. Okay, but for today, we want you guys and girls to understand that the two lines coming off that secondary are 240 volts, but this is the trick. We've got the ability to break off and create what we call the neutral. So now let's continue a little bit further with that line. And we get to your house. You're now going to branch off from that electrical panel of your house. When you go there and open up the little door, you'll see all these different little circuit breakers or switches that will turn different things on and off your house. Don't touch them! Don't get me in trouble. But by looking at them, you'll understand that each section of your house is broken off into separate branches or separate circuits that will control different things. So what I've just drawn here is just an electrical symbol for a circuit breaker. In my eyes, it's an upside down smile face, if that makes sense to you. And from this circuit breaker, we will come off what we call our hot wire. And our hot is consistent of one of those two lines, line 1 or line 2. The neutral coming off that transformer outside your house is going to connect to what we call, inside of the electrical panel, the same place, the neutral bar. That's what the N is for. I just do dashed lines here to indicate the white. Okay, that's going to be more white color, but on a whiteboard, white doesn't show up so good. So I'm just going to do dashed lines with a black marker. And I'm just going to remind you that this is my neutral. Now, I said white to you. We don't really get into color coding yet, but we do know that electricity is colorblind, which means that it doesn't matter what color the wires are, it's still going to work the same way. The whole purpose of the color coding is for me and you, and that's for us to understand where things are going. So color coding is for the human, the individual, installing and maintaining the system to have an understanding about how the system works, okay? So we're going to keep this consistent with being white. And off of that neutral, we will find the same theory there that it is still bonded or connected to the earth, and that will provide our ground. So in your house, on a typical small appliance circuit, or any circuit that was 120 volts, you've got 3 wires to deal with. You've got the hot, you've got the neutral, and you've got the ground. That neutral will always be identified as a white color inside of your house. The hot will be either black or red in your house. The ground will either be a bare copper color or green in your house. So this is a little bit about the branch circuitry in your house. We're going to continue that further as we go. Hopefully we get you in here and start building some circuits soon enough. See you guys soon.